Derive the Weingarten's equation or product of h square n1 equals to fm minus gl into r1 plus fl minus em into r2, and h square n2 equals to fn minus gm into r1 plus fm minus en into r2, and deduce h into n1 r1 equals to em minus fl, and second h into n1 r2 equals to fm minus gl. Now proof: since n is a vector of the constant magnitudes, therefore its first derivatives n1 and n2 are the perpendicular to n, and hence they are tangential to the surface. Thus both n1 and n2 lie in the plane of the vectors r1 and r2. So n1 equals to a into r1 plus b into r2, equation 1. n2 equals to c into r1 plus d into r2, equation 2, where a, b, c, d are the constants values to be determined. Taking the scalar product of the both sides of equation 1 with respect to r1 and r2, we get n1 dot r1 equals to a into r1 dot r1 plus b into r2 dot r1, or this equals to minus l equals to ae plus bf, equation 3, and n1 dot r2 equals to a into r1 into dot r2 plus b into r2 dot r2, or m minus m equals to af plus b g, equation 4. Now 3 and 4 can be written as ae plus bf plus l equals to 0, equation 5, and af plus bg plus m equals to 0, equation 6. Now solving 5 and 6 for a and b, we get a equal to fm minus gl equals to b upon fl minus em equals to 1 upon eg minus f square. So a equals to fm minus gl upon ag minus f square, and b equals to fl minus em upon ag minus f square. Putting the values of a and b in equation 1, we get n1 equals to fm minus gl upon ag minus f2 into r1 plus fl minus em upon ag minus f square into r2, or n1 equals to fm minus gl upon h square into r1 plus fl minus em upon h square into r2, or h square n1 equals to fm minus gl into r1 plus fl minus em into r2, equation 7. Now taking the scalar product of the both sides of equation 2 with respect to r1 and r2, we get n2 dot r1 equals to c r1 dot r1 plus d r2 dot r1, or minus m equals to c e plus df, equation 8, or n2 dot r2 equals to c into r1 dot r2 plus d into r2 dot r2, or minus n equals to c into f plus d into g, equation 9. 8 and 9 can be written as c into e plus d into f plus m equals to 0, equation 10, or c into f plus d into g plus n equals to 0, equation 11. Solving 10 and 11 for c and d, we get C upon Fn minus Gm equals to d upon Fm minus En equals to 1 upon Ag minus F square. So C equals to Fn minus Gm upon Ag minus F square, and D equals to Fm minus En upon Ag minus F square. Now putting the values of C and D in equation 2, we get N2 equals to Fn minus Gm upon Ag minus F square into R1 plus Fm minus En upon Ag minus F square into R2, or N2 equals to Fn minus Gm upon H square into R1 plus Fm minus En upon H square into R2, or H square N2 equals to Fn minus Gm into R1 plus Fm minus En into R2, equation 12. Now equation 7 and 12 are called as the Weingarten's equations, deductions. Since the Weingarten's equations are H squared N1 Fm minus Gl into R1 plus Fl minus Em into R2, equation 13, and H squared N2 equals to Fn minus Gm into R1 plus Fm minus En into R2, equation 14. Now taking the cross product of the both sides of equation 13 with R1, we get H squared N1 cross R1 equals to Fm minus Gn into R1 cross R1 plus Fl minus Em into R2 cross R1, or H2N1 cross R1 equals to Fl minus Em into R2 cross R1, because R1 cross R1 equals to 0, or H squared N1 cross R1 equals to minus Fl minus Em R1 cross R2, because R1 cross R2 equals to minus R2 cross R1, or H squared N1 cross R1 equals to Em minus Fl into Hn, because R1 cross R2 equals to Hn, or N1 cross R1 equals to Em minus Fl upon H square into Hn. Now H equals H into N1 N1 R1 equals to Hn dot N1 cross R1, which is equal to Hn dot Em minus Fl upon H square into Hn, equals to Em minus Fl, because N1 dot N1 N dot N equals to 1. Now taking the cross product of the both sides of equation 13 with respect to R2, we get H squared N1 cross R2 equals to Fm minus Gl into R1 cross R2 plus Fl minus Em into R2 cross R2, or H squared N1 cross R2 equals to Fm minus Gl into R1 cross R2, because R2 cross R2 equals to 0, or N1 cross R2 equals to Fm minus Gl upon H square into Hn, or H into N N1 R2 equals Hn dot N1 cross R2 equals to Hn dot Fm minus Gl upon H square into Hn equals to Fm minus Gl.